different salts and deciding whether they're acidic, basic, or neutral. We have Na and CO3. So that's going to dissociate into Na, and that is the conjugate of NaOH, which is a strong base. CO3 2 minus is the conjugate of H2CO3, or really you could look at HCO3, which is a weak acid. So if we look at how that would react with water, we would get plus, it would pull off a hydrogen and you'd get OH minus, so that's going to be basic. So whenever we have the conjugate of weak acid, the solution is going to be basic. If we look at NaNO3, Na is the conjugate of NaOH again, which is a strong base. And NO3 minus is the conjugate of HNO3, which is a strong acid. So this one would actually be neutral. And then we look at Kf. So potassium is the conjugate of KOH, and F is the conjugate of HF. So just, if I didn't mention it before, your positive ion majority of the time is going to be the conjugate of your base most of the time. And your negative ion is going to be the conjugate of the acid. So that's why you can kind of see the base is the first one that we look at, and then the acid is the next one. Looking at Kf, KOH is a strong base, so that one is neutral. HF is a weak acid, which is honestly very often mistaken for a strong acid, but HF is a weak acid due to how small the fluorine atom is. So this one would be a basic solution, and we can see that by F minus from the Kf reacting with water, creating that HF. It would pull the hydrogen off, and you'd be left with OH minus, so that one would be basic.